Yeah, my name is Raj Subramanian, and first of all, I wanted to just say thanks for coming to today's session because I know there's a lot of great sessions going on in parallel, and you chose to come here, so thanks for that. So before I start, I just wanted to get a sense for the audience here, right? So I was going to ask you a couple of questions. First question is, how many of you are confused in terminologies when it comes to AI, neural networks, deep learning, machine learning, and how it applies to test automation? Okay, majority of people, that's good. How many of you think in the next 3 years they're going to be AI-powered robots who are going to take over the world and we're going to be slaves to them? See, me too, yeah. So I have some good news and some bad news, right? The good news is I have the answer to the first question, and that's the talk today, where I'm going to cover some basics of AI, neural networks, and other terminologies which you hear, so that everyone is on the same page when I actually talk about AI. And then the second half, I'm going to talk about how AI is applied to software testing, more specifically test automation, right? That's the good news. The bad news is, yes, I don't have the answer to the second question, but I know the next Terminator movie will definitely cover that. So with that being said, let's get into today's talk. So this is a little bit about me. First things first, so I work for a company called Testim. So what we do is we use artificial intelligence for the authoring, execution, and maintenance of automated tests. Our focus is on functional testing, end-to-end testing, and UI testing. So what I do for the company, so I'm a developer evangelist. What that means is I write all the content for my company, blog posts, technical publications, and then I speak at conferences, and that's kind of 20-30% of my time. The other 30 to 40% of the time, I'm in charge of the entire U.S. customer base from a technology standpoint. So anything technical comes to me. And then finally, I work with R&D to make our tool better because I have about 12 years doing test automation. I was first a developer and then got into test automation. So I have a lot to offer and make our tool better. So that's about me and my company. I regularly share my thoughts and ideas on different testing topics, leadership topics, on different blog posts and publications. So those are the links, and you can just check it out when you get a chance. So this is going to be the agenda for today. So first, I'm going to cover the basics of AI so that everyone is on the same page when I talk about AI. And then I'm going to talk about what are the current challenges with test automation, and then how AI can help to solve those challenges, right? And finally, I'll finish up with different cool things which are happening in terms of AI and software testing, which you may not know, but I'm going to show it to you as well. So first, let's start with the basics of AI, right? So on a high level, we have what is called artificial intelligence. So what is artificial intelligence? Artificial intelligence, or AI, is an area of computer science which deals with building computers that can work and think like human beings, right? So that is AI. And a subset of AI is what is called machine learning. So machine learning is a field of study that deals with giving the computers the ability to learn without being explicitly programmed. So that is machine learning, and it kind of evolved from the study of pattern recognition and computational theory. Computational theory is the study of learning algorithms, so that's how machine learning evolved, right? And then finally, we have what is called deep learning. So deep learning is just a subset of machine learning, and it kind of evolved based on the neural network of our brain in the human body. So in our human body, there are billions of neurons which interact with each other, and all the reactions we do, like raising our hand, blinking, speaking, everything is based on this interaction, right? They took that concept into computer science, and that's what is deep learning. So whenever people say deep learning, neural networks, it's based off the neural network of the brain, they kind of mimic that and put that in the computers, put that in computer science. So this kind of the brief classification where those three things fall under, right? So when you talk about machine learning, there are three classifications, and this is what you're going to hear a lot of people talking about, right? So let's demystify these terminologies a little bit. So first, we have supervised learning. So supervised learning is trying to make predictions on future values based on learnings from past experiences, right? So you give a labeled data set and then train the AI model. So what I mean by that, say for example, you're building an AI model to recognize buttons from an image, right? You feed in an image and you want an AI to recognize buttons. So what you're going to do if you're doing supervised learning is you're going to feed in different input combinations, which is you'll feed in a rectangular button and say rectangle. Then you'll feed in a round button and say round, square button and say square. Then you'll feed in something which is not a button also, right? So you're giving labeled data sets to train the AI model. So that is supervised learning. And when you talk about supervised learning, there are two models which are actually used. You have what is called the regression model, and then you have a classification model, right? So what's a regression model? So to make it really simple and more understandable, let's take an example, right? Say you want to build an AI model to predict, say you have a restaurant, and you want to build an AI model to predict how much tip amount people give in a 2-hour time frame. Say you want to build an AI model for that, right? So the tip amount could be 5%, 10%, 2%, 1%, 0%. It is varying set of values, right? So when you have situations where you want to make predictions on various set of values, which could change, like the tip amount, then you use what is called a regression model, right? Then you have what is called a classification model. So let's take the same example. Now, say you want to make predictions on how much tips a male gives compared to a female, right? There's only two possible combinations, male, female. It's a finite data set. They're never going to change, right? And you're trying to make predictions on male and female. So then you're going to use a classification model because they're just finite data sets you're trying to make predictions on, right? So this is the basic classification. And you're going to also hear people use words loosely like labels and features. So what labels are basically the things you want to make predictions on. They are called labels. So the tip amount is a label, then male and female, that's a label. And all other attributes which could help to make that prediction is called features. So for example, the restaurant location, the time of the restaurant, the space of the restaurant, all the other factors which could help to make the prediction, right? Those are called features. So you have labels, you have features, okay? So some examples of supervised learning would be giving a bunch of audio and getting text from it, then giving a bunch of email and predicting spam, which email is a spam. And how many of you have Hulu, Netflix? Pretty much everyone, right? Yeah, because it's 2019 now. So, but the point is, so whenever you log in, say Hulu, right? You get a bucket which says recommended TV shows, recommended movies, right? The way they could do that is because of supervised learning, because they're learning from your usage patterns, right? So that is supervised learning. Then we have what is called unsupervised learning. So unsupervised learning is used to make, you give a bunch of data sets which are not labeled, and you want to see what patterns can come out of it, right? So that is what unsupervised learning is. And the model used for unsupervised learning is called a clustering model. And so these are the basics of how they use supervised and unsupervised learning. Some use cases for unsupervised learning would be like AT&T, Verizon, all those cellular companies. They use unsupervised learning for targeted segmentation. So what that means is they give different advertisements. So say I live in Chicago. They would give different advertisements for people under 30, and they'll give different advertisements for people over 60 for the same region. So they could do target segmentation using unsupervised learning. Then finally, you have what is called reinforced learning, and this is what we hear these days, like in autonomous cars and so many other things which are happening are basically reinforced learning. So what reinforced learning is, you're rewarding good and bad behavior. It's based on reward functions, right? So what that means is, let me give you a raw example. So how a baby learns to crawl is a great example for reinforced learning, right? So a baby first crawls, then hits his head against the wall, if it was a baby like me, and then it tries to get up by keeping one foot in front of the other and falls down. Then it knows it should not do that next time. And then finally, after a lot of trial and error, it finally gets up and starts walking, right? That's a simple, raw example of reinforced learning. And the same thing applies for autonomous cars as well. So you'll feed in different images of a left turn, a right turn, a straight turn, a U-turn, and then if you feed it a straight image, image of a straight road, and if the car moves to the left, right, you would say bad. No, you should have gone straight. So we constantly keep training that AI model, right? Anyways, these are all the terminologies you need to know. When people use these terms loosely, this is what they actually mean, okay? And then, so you would have heard of deep neural networks. So I'm not going to get too much into the details, but I just want to let you know how it works. So we have what is called different inputs. Then you have different weights. So you combine the inputs and the weights, and then it goes through what is called an activation function. Again, it's just a mathematical function. And those activation functions could be sigmoid or tangent or ReLU or ELU. ELU is exponential linear unit. But anyways, the point is these inputs and weights go into a mathematical function, and then you get some outputs, right? So this constant iteration is basically what happens in deep neural networks. So just to give you a raw example of how a neural network would work is, so I don't have the diagram here right now, but the point is, say for example, you want to create an AI model. So say you're moving into Chicago, and you want to create an AI model to know how much price you need to pay for the house you want, right? So you can use deep neural networks for that, where you'll input different parameters like the price, the location of the house, then the number of bedrooms you want. So you can feed in so many different inputs that would go in the input column, and then you'll give some weighted sums, and then it'll give you an output saying this is a good location, right? But anywho, the point is, that's how deep neural networks work. Just to show you a live example of how you can train an AI model, and again, I usually show this at conferences because to give you a visual idea on how anyone can train an AI model and see how it works. So there's, how many of you have heard of an app called QuickDraw by Google? Okay, cool. So what QuickDraw is basically an open source tool where, based on what people are trying to draw, the AI will try to predict what you're trying to draw. And Google is super smart because they made it super fun and addictive, so many people have used it, which means that they've got so much data to train that AI model, right? So let's give it a shot, and then this is a live example of how to train a neural network, right? So right now it says draw a jacket in under 20 seconds, so let's see what happens.
I see paperclip, or potato, or lollipop, or person. I see yoga.
Drawing is not my forte, by the way, so.
I have no clue what you're drawing.
So, I'm trying to draw a jacket,
I'm
but
stumped.
it's really hard without a mouse, by the way, so it's not my fault. Okay,
Sorry, I couldn't guess it.
Okay, let's try a butterfly, so.
I see broom, or marker, or crayon, or paperclip, or X. Oh, I know, it's butterfly.
There you go, right? Even with my shitty drawing, pardon my language, but it's still the AI was able to predict it, right? So this is an example of training an AI model. Let's do one more drawing. It's fun, right? So let's do this.
I see line, or broom, or leg, or fork, or jail, or golf club. I see hockey stick, or wine bottle,
How do you do
or
an
marker.
X? Okay.
I see pencil. Oh, I know, it's X.
There you go, right? So again, I can keep playing, but the point is there's only so much time. But the point is, so that's an example of an actual neural network. So if you want to know how to train a neural network, you can use Quick Draw for an example. And if you relate to all the concepts which I just mentioned, the inputs are basically all the different diagrams you're drawing. That's the input. And then they would have trained the AI model saying, if I draw an axe correctly, it's an axe, right? So you constantly, after training those AI model like that, it now knows exactly what you're trying to do, right? It's creepy, but it's super smart. So anywho, so that's an example. And these are some open source frameworks to create your own neural network. My personal favorite is brain.js, which I'm currently working on. So I do another talk on how to build a neural network in under 5 minutes. So yeah, the point is if you want any information on doing stuff, just hit me up after the talk. But brain.js has a lot of support online, so you can find a lot of sample code and do stuff. And I also have my Git repo. I think I forgot to put that link here, but just email me. I'll send some samples. Cool. So now we covered all the AI bases, right? So when I use different terminologies, you know what I'm trying to say. So now let's get into the real meat of the talk. So what are the current challenges with test automation and why we need AI now to solve those challenges, right? So first, let's talk about what are the current challenges with test automation. So in the past 30 years, it's been the same set of challenges again and again when it comes to test automation, right? Let's quickly cover them one by one. So the first challenge is the challenge of skill set. So getting skilled developers and testers, it's hard, takes a lot of time, takes a lot of money. A lot of small companies cannot afford doing that, right? So because of that, what happens is you test everything manually, and then you're not able to release products faster, and then you lose the competitive edge, and because of that, there's a lot of problems, right? So skill set is the first big problem, specifically when it comes to test automation. Then you have the challenge of authoring. So now say you got some money, and then you recruited some developers or testers to write some automation code. Well and good, but the point is they forget to pay attention to the best practices of doing test automation, like doing data-driven testing, doing parameterization, making reusable components. They fail to pay attention to that, and that leads to a lot of problems in trying to maintain this automation framework, right? So next challenge is the challenge of initialization states. So what do I mean by that? I'm pretty sure most of you are aware of Amazon, so that's why I've used this as an example. So say, for example, you're writing an automation script to add items to the cart, right? So you write a simple automation script, and then you're super happy. Yes, it add item to a cart, right? What happens? So what happens when you actually run that script again? So usually, if people do not pay attention to what they're doing, you'll start adding 2, 3, 4, 5, 6, 7, 8, 9, 10 items in the cart every time you run the test. That's because people fail to pay attention to have setup activities and teardown activities, right? And bringing the application back to the initial state of where it was. So that is really important, and by not doing that, that leads to a lot of problems as well. The fourth challenge is maintenance. So this is the biggest problem with test automation, and it's been there for the past 30, 40 years right now. So how many of you have had the situation where you write 10 tests, you've worked the whole day for it, and next morning you come and see that all 10 tests are failing, right? Pretty much everyone has been there, right? Exactly. So maintenance is a nightmare, and according to a recent study, 30% of a tester's or developer's time goes in test maintenance, which is crazy. So even if you're able to shave off 5 to 10% of that, imagine how much time you can get back and do other useful things, right? So maintenance is the biggest challenge, and that's what we'll be talking about mainly today as well in terms of AI and how it helps to solve the problems of maintenance. Then finally, you have the problems of scale. So now you have 500 tests in a test suite. You run it, and the next day you come and see that 100 tests are failing. and then you have to spend pretty much 4 hours trying to troubleshoot what's happening, why it failed, right? So as and when you scale your automation framework, that has its own problems. And when you talk about scale, it's not only your automation suite, you also need hardware resources to run these tests, because you want to run so many tests in parallel, you want to get faster feedback, you need to run more tests consecutively and find bugs faster, right? So scale is also a big challenge when you do test automation. So that's where we can use AI to solve some of these challenges, and now I'm going to show you and talk about it a little bit to make you understand what people are currently working on in terms of AI and testing, and especially test automation. So there's this concept called dynamic locators, and that's going to be the next big thing in test automation. We use dynamic locators, and I know a couple of other companies and my colleagues have been trying to implement that in test automation as well. So what are dynamic locators, right? Say, for example, you have a login page, and you have a login button, right? Say you change the name of the login button from login to submit. What happens when you run the test automation if you're using the name attribute? The odds are the test is going to break, right? Because you changed the name attribute. And this is the problem with all the existing frameworks and tools, because they're using a single attribute to locate a single element on a page. And that is the biggest problem. That's where dynamic locators come in. So using AI, what we could do right now is we can extract, in real time, extract all the DOM attributes for every element you interact with on the page. So as a result of that, what's going to happen is, even if one attribute changes, you have other attributes to look at to locate that element. So for the same example of login button, if you change the login button to submit, and if you use dynamic locators, the test won't break. That's because if the name changed, then the AI would say, I see that the name changed, but let me look at the ID attribute, because I've already extracted everything related to that button. Oh, the ID changed? Let me look at the class attribute. Oh, the class changed? Let me look at the tag attribute. Oh, the tag attribute changed? Let me look at the parent-child relationship, so on and so forth, right? So this is where AI is going to be really helpful, and people are using it, including us in our company as well. And I'm going to show you how we actually do that, right? And as a result of this, what happens is you're going to spend less time in maintenance, because every time something changes in the UI, you don't want to go sit and fix tests, right? You want your test to be smarter to adapt to those UI changes. And the more tests you run, the smarter the AI is going to become to actually detect those changes as well, right? So just to show you an example of how people use reinforced learning in test automation, I'm just going to take a sample website and show you a live demo just to give you an idea of how dynamic locators work, right? And again, different people implement this in different ways, but I'm going to show you how we did it, and just to give you an idea. So I created a sample web application for the demo. So I'm just going to go ahead and start recording a test. So I'm just going to log in, enter a username, password. I'm going to select some dates. Click on select destination. So this is just a sample itinerary booking application. I needed something to show something. So I'm doing a scroll, clicking on book, and I'm entering my name. And I think that should be good for now. So I've recorded the test, and just to make sure I didn't mess up anything, let me just replay the test, because sometimes I just click randomly. So it's just going through the same flows right now. It's entering my username, password, and then selecting dates from a date picker, selecting the select destination button, going to go ahead and book my itinerary and enter my name. Okay, cool. So things are working properly. So remember I was talking about reinforced learning? So this is how we use it. So if you take any attribute, any element which I interacted with right now, you're going to see the different things happening. So if you see over here for the select destination button, you have the text attribute, the class attribute, the type attribute, the tag attribute, and so on and so forth. And for each attribute, there's what is called a scoring system. And this is how they train autonomous cars as well, where you're going to have two factors when training autonomous cars. You're going to have what is called a risk score and a confidence level. That's how you know whether the AI model is performing well or not, right? So if you see over here, you see the text attribute has a score of 0.9, which is the highest possible score. So if the text attribute change, what's going to happen is it'll go to the attribute with the next best score, which could be either of these class attributes, right? And again, we don't have to deal with any of these. The AI in real time takes care of this, but I'm just showing you how reinforcement learning works from the DOM perspective. And if you see, right now it's 100% confident that it's going to locate that select destination button. I'm going to now simulate a scenario where a developer comes and changes something, and I'm going to show you how the AI reacts to that change, and that's going to be the value you get. So quickly what I'm going to do is just putting a breakpoint here. So I'm just going to run the test until the point it clicks on select destination button. Then in real time, right now I'm going to show you how the AI adapts to changes in the UI, right? Then you're going to get an idea on how AI can help out. Okay, cool. Test reached a breakpoint. Okay, so what I'm going to do is I'm going to make changes to the select destination button. Man, without a mouse, it's really hard. But anyways, so say, for example, I move the select destination button, right? So I'm going to move it from here to here. So I move the select destination button, as you can see. And then, instead of select destination, say DevOps is awesome. You can go ahead and change the ID as well if you want. Then I can keep changing more attributes. So I can keep changing more attributes, but we have only, again, so much time. So as you can see, so I changed the location of the button. So if you're going to use XPath for your test automation, the test is going to break because I changed the DOM structure. I changed the name. If you're going to use the name attribute, the test is going to break. I changed the ID. If you use the ID attribute in your Selenium or other scripts, it's going to break, right? And I'm mimicking a normal scenario which happens. Trust me, I've been doing test automation for 14 years, and it's always a nightmare for me. But now, see what happens when I play this test. So let me see whether I'm going to click on play, and there you go. It still was able to locate the select destination button in spite of changing the location, the name, the ID, and the test still continues to run, right? That's the beauty of dynamic location strategy, and that's going to be the future of test automation. So already companies are doing it, and I'm currently working with another person try to open source some of these things so that people can use it in other systems as well. But this is going to be the future. Just to quickly wrap this dynamic location strategy discussion, just to understand what actually happened right now. So if you see the screenshots, the AI tells you that, hey, what you expected was a select destination button, but what I found was DevOps is awesome, right? But the reason it didn't fail the test is because the functionality still remains the same. No matter whether you click on DevOps is awesome or select destination, it still went to the checkout screen, right? Imagine you have 500 tests. Just because a person changed a name in the 300th second test, you don't want the rest of the test to fail, right? That is the biggest problem. So what now it's going to happen is, no matter what you change in the UI, the AI adapts to that change. And then in the end, it's going to tell you what changed, what didn't, but it's not going to fail, and helps to reduce the maintenance times. And if you look at the locators again, just to show you. So if you see right now, it says the confidence level is 83% because I changed the text attribute and the location, the confidence level decreased. And if you see over here, it's showing you what attribute actually changed. So I changed the text attribute. So what happened was, in real time, it went to the attribute with the next best score, which could be either of these class attributes. But again, we don't have to worry about it because the AI takes care of it. So that is dynamic location strategy. And that's what we and a lot of people are trying to work on. So don't be surprised if you're using Selenium or any other frameworks, they're probably going to move to this because this is a more stable way of doing UI automation, right? So that is dynamic location strategy. And this diagram graph is a really good one from my friend. So the problem is, as the complexity of software over time increases, right, the features, the complexity of the features are increasing exponentially, but the test coverage is growing linearly, and there's this huge gap in the middle, right? So that's what AI could help in solving, right? That is something to keep in mind. So next, the final segment was talking about the future of AI. What are the cool things happening in AI right now, right? Some people may be aware of it, but some people may not be aware of it, so I just wanted to let you know what are some cool things we and other people are working on. So first thing is autonomous testing. How many of you have heard of autonomous testing before? Cool, yeah. So currently what we do is we make a lot of assumptions on how the user is going to use the app or whatever applications you have. And then you build automated tests and then write manual test cases, right? You make a lot of assumptions. But right now, with autonomous testing, what you could do is you can have the AI learn from how the user uses the app and then create scenarios based on that, right? So say, for example, you have a login application, right? I mean, not login. Say you have your insurance, auto insurance application, and you have to log in. And every time, if you log in with Raj123 and click on login, Raj123, click on login, if you do that 50 times, what the AI could do is it would say, hey, you try to log in with the same freaking username and password. Why don't I create a reusable component for you and create a test out of it, right? So it's going to monitor how you use application, create tests for you. This is something we've already implemented and it's in alpha, but a lot of people are trying to work on autonomous testing to make your test much smarter, right? Oops. The other thing we're working on is UI TDD. So you have heard of BDD, TDD, SDD, which is Stack Overflow Driven Development, and then now you have UI-based test-driven development, right? Just to add to the confusion, but it's super cool though. So what's going to happen right now, and currently we are testing this out. So what you could do is you could feed in, so I'm assuming most of the people are in agile environments where they'll give you a mock-up, and based on the mock-up, you start developing features, right? Because you have no idea how it should look unless you get some mock-ups from the designers. So when you get these mock-ups, what is going to happen is we can feed the images to the AI, and the AI can detect all these features and start creating tests based on image recognition, while the developer is actually trying to implement those features based on the mockups. So what's going to happen is by the time the developer actually finishes implementing the features, you already have tests written based on this image recognition, and just run the test against the developed feature, right? It's super cool. It helps to save a lot of time. So UI-based test-driven development is something people are currently working on, and something you can expect in the upcoming months as well. And then, yeah, automatic responses. So say, let's just take that insurance application, right? 50 times I try to use the same username and password and click on login. I don't want, for the same user credentials, every time I don't want to go hit a server and get the response back and wait for it. Instead, with AI, what we could do is we could have a middleware, like a middle layer, where if there's commonly used username passwords, it can record all these commonly used requests and then saves the responses and immediately, for the same username password, immediately send a response without going to the server. So what's going to happen is, especially in the context of UI test automation, your tests are going to be much faster because every time you don't have to hit a server, right? So that is something which is going to be really valuable. And this is something which people are currently working on as well. So, but yeah, so those were pretty much different things I actually wanted to cover. So I wrote a detailed blog post mentioning different resources and different links to things I talked about. So if you go to this blog post, you'll find a summary of all the things which I just discussed, right? And yeah, so now I'm open to questions. And before you leave, just make sure, if possible, fill up the feedback form, because that's how I come up with interesting topics and things to talk about. So thanks for listening. Thank you. So I can take questions. So we had a question there. Yep.
So when the test actually passed, you changed the text of the button, your AI actually made it pass, but that should have failed. If something like that passes and it goes on and continues something, that keeping AI in the wrong direction.
Great question. So the reason we use AI is for adapting to changes and reducing maintenance time, but you also have the option of overriding what the AI learns. For the same example of select destination, we already have inbuilt functions where you can fail the test if you detect a text change, or you can fail the test if you detect a location change. So you have built-in assertions, so you can override what the AI learns. But imagine, again, that you have 500 tests, right? Just because a name change, you don't want the rest of the test not to run. And so what's going to happen is, although it automatically adapts to changes, in the end, it's going to give you a report of what actually changed, right? So great question. So if you really want to catch those issues, you could add your own assertions and stuff. In our platform, we already have inbuilt assertions for doing element text visible. Is element visible? Is the text visible? You have inbuilt wait statements. You have inbuilt API testing as well. But again, so yeah, we can catch those things and override the learnings as well. So we have two questions there. I'll go here first. Yep. How it decides to override and not to override? Great question. By default, it's going to be smart and then try to adapt to changes. But if there's something specific you want to catch, like a text change or a location change, then you can add your own assertions to do that, right? So this is the thing. For the past 7 years, we have been training our AI models on different applications. You probably heard about our company only for the last 2 years, but for the past 7 years, we have been training the AI model. What that means is we have given our AI model different websites on AngularJS, React.js, Vue.js, Ember.js. So odds are when you come and use our application, it already knows what are the problem areas. So that's how it's able to adapt to changes because of this constant learning. So say you come from a React.js framework, we already know that one of the problem areas of React.js frameworks are the rich text editors because they use WYSIWYG editors. And a lot of automation tools and frameworks have problems dealing with that, but we have already solved that by training the AI, right? So that's the basics of how it's learning. So based on the learning, it will adapt to those changes, but if you want to override something, then you add your own custom steps and assertions. So, yep. Yep, so I can speak only to my company. So yes, we do mobile web apps, desktop web apps, mobile native applications, both iOS and Android as well. And also you can add your own custom code using JavaScript. So if there's some functionality we don't provide, you can add your own code. So we provide that flexibility as well. And just to your point, so if you see you already have inbuilt validation steps to validate element visible, text, downloads, then you can add custom validations using JavaScript. And then you have other things you could do as well. So, but anywho, just wanted to give you that idea. So you have a question there, yeah? Thank you.
How do you have data changes on the back? So let's say if I have test brought different data sets, how do you analyze where write different things, or does AI handle it automatically?
So there's no AI piece in that. So we have different ways to organize your test data. So within the tool itself, you can give whatever test data you want, or you can have an external config file for dev environment, one for staging environment, one for production environment, and during runtime you can pass that test data set. So based on what config file you're passing, it's going to take those data sets. So you have a lot of options on how you want to do your maintain and use your test data. So yeah, we do have multiple options. Yep.
Adding more technical debt over a period of time to the test code base. Because now we have an issue and AI automatically took it over and will show its loss. Over a period of time, adding more technical debt.
So the question was, now since AI is smart and automatically adapting to changes, does it add more technical debt in the end? Because now we're adding more complications where it's automatically adapting to changes. No, really valid question. So the thing is, what kind of changes the AI adapts to, right? Remember, only if there's an attribute change, the AI adapts to it. But if there's a change in functionality, you are going to see the test fail. So for the same example of select destination button, clicking on the DevOps is awesome button, it still went to the checkout screen because the functionality still remained the same. That's the reason why it adapted the change. But clicking on DevOps is awesome doesn't go anywhere, then the test is going to fail. So it's just going to be, you're going to get the same feedback which you're getting right now with your current existing tools and frameworks. But the point is, you have an added advantage that for minor attribute changes and stuff, you don't want to fail the test. And in the end, you're going to get a report. You get emailed reports on every test run. There's a lot of settings you can do with testing. You get emailed reports on what attributes change, et cetera, et cetera. So yeah, so we try to handle that by reporting and making sure only the attribute changes are being adapted, not functionality changes. So let's go here. Yep.
Do you have a sense of, there is a risk, there could be a risk that you make a change, the AI clicks the wrong button that still takes you, for example, to the card page. And over time, basically the test should have failed because the AI made a mistake, but it could be that the test still passed. And so basically, you would learn a new behavior that you may get masked, you may not find out, right? Because
Yep.
you failed the test.
Great question. So I don't know whether in the back you heard the question, but he was saying, what if the AI makes a mistake, and then how do you actually control that, or how do you manage that, right? Nothing is 100% perfect. We have had one or two cases where the AI couldn't recognize an object, although it was right there in front of your eyes, right? So that's why what happens in the testing world is we have separate databases for different things. So we have a separate database where issues like this, when it happens, I can flag it from my end because I'm an admin user. I also own the tool, by the way. But I'm admin user, so I'll flag it. And what happens is that failed test goes to Israel in our database, and there are data scientists looking at these issues and then putting patches constantly to the AI. Reinforced learning, remember? So what we would say is, bad AI, why did you not recognize this? You need to recognize this and then put a correct result, and then the AI adapts to that so that next time it doesn't do the same mistake. So that's how we're trying to manage those cases. But yes, you could always may have one or two cases where the AI commits mistakes, but it's just this constant training which we are doing. So.